Okay, so here I am in small screen, and you have the main screen is the BioPack system, and this BioPack is a physiologic data collection system that I bought so that I would have it to teach with, and it has come in very handy. It does a super number of things. We already saw it with EKG and pulse velocity, and it'll even do biometric, it'll do oh, forget it. Bioelectrical. Hello. Okay, so here I am in small screen, and here is the BioPack system set up. It does a variety of really interesting things. We can do lung function, we can do nerve conduction, we can do pulse rate velocity, we can even do a lie detector test on it. We can do EEGs on our brain with this thing. I bought it so that I would have one to teach with, and it's turned out to be really handy. So what I have it set up right now for is that lung function test, the PFT, the pulmonary function test. It's going to give us a lot more information than just the inhale, exhale thing. When I'm in the middle of my test, I will do that, and we'll use those numbers as though I just had a simple PFT machine and just sucked in and blew out, and we had only those numbers. But it's going to be kind of embedded in all of the information that I have. First of all, it's going to want me to calibrate this thing so that it knows what the numbers, what zero really is, and comes up with, a true number for us. So here I'm going to hit calibrate, and first thing I do is let it calibrate 0. It's got to calibrate 0 first. Okay, and now I'm going to do this, and I'm going to do here, wait a couple seconds, here, wait a couple seconds, here, wait a couple seconds. Okay, so now it should be calibrated. And now we'll be able to record. Okay, so I'm going to take this calibration syringe off. Put it away. So what I'm going to do first is I'm just going to breathe normally for a while. And the hardest thing in the world to do is to breathe normally when you're told to breathe normally. When you think about breathing, you have a tendency to affect your breath rate. So I'll see how close I come to normal breathing, normal size tidal volume. Normal size tidal volume is somewhere around ½ a liter that you breathe in and breathe out at rest. As one of our students pointed out, she works in a dentist's office, and if they're going to give somebody nitrous oxide, they have to determine their tidal volume first, because you have to know how much air the person's moving so you can get the concentration of the gas right. Otherwise, you give them too much or too little. So I'm going to establish my tidal volume. Then I'm going to breathe in as deep as I can, and I'm going to blow out as much as I can so that we can actually see what my inspired reserve is and my expired reserve, and thus my vital capacity. Okay, so let's do this and see if I can make it work. Record. Okay, see if I've done a good job here. I'd rather not have to do that again if I could help it. Okay, so this is the flow rate. Okay, so this shows how much it was flowing on my inhale, how fast. So there would be my peak expiratory flow, because that's when I was blowing as hard as I could, and it came out really fast, and then it started to decrease as my airways got compressed. This thing on this actually winds up being upside down. Remember, you blow, and then it comes out, and then you inhale, and it goes. Normally the inhale is on the bottom in a typical PFT, but here we have our two flow rate curves, and here we have the volumes. So I'm changing from here to here when I breathe in and then blowing it back out again. So this is a tidal volume. This is kind of a typical tidal volume for me anyway. And from, let's say from 4 to 14, I was 3 and 10 seconds, 6, about 18. So, my breath rate was maybe 16 to 18 breaths a minute. We're going to use 12 because that's kind of average for somebody who's relaxing. I obviously was breathing a little bit faster because I was on TV. But anyway, typical breath rates for humans at rest is 12 up to 20 is okay, is typical, but we'll use 12 simply because that's typical. Okay, so I'm going to say I'm done here. Yes, I'm sure I'm done. I'm going to look at the current data. Okay, so there's my current data. Looks pretty good. So what I'm going to do is I'm going to make some measurements here. I'm going to see from the bottom of one of these breaths to the top of the breath how big it was. And in this case, it was 0.42 liters. Now, this is the difference between P and P, position 1, position 2. So that's my delta number here. Okay, 0.47. It's pretty close to half a liter. I was kind of close to 0.67. It was a little bit bigger breath that time. How about this one? It was 0.42. So I could write down exactly what it was, somewhere between 0.42 and 0.6 something. Okay, 0.42, 0.49. Let's say my tidal volume was a half liter. I've measured it close enough. If I can keep round numbers for you, it's going to make it easier for you to do the calculations. So let's say that my measured tidal volume was actually the half liter that we expected it to be. So I write down, I write down in my data sheet, I write down resting tidal volume 0.5 liters or 500 milliliters. Sometimes it's going to be easier, depends on what units you're using. You might have to use milliliters. Okay, now from the top of, say, a typical inspiration to the top of my maximal inspiration, looks like 4.4 liters. Let's see from this one. 4.4 liters. So my inspired reserve from the top of, a normal inspiration to the top of my maximal inspiration was 4.4 liters. Okay, let's see what this is from here to here. Okay, see that isn't doing it right. So I'm going to go from here, which is right even with that. That's even with that. Let's go from, because 4.4 is kind of big. Let's go from there to the top. Yeah, that's more like it. About 3.9. 3.9 liters. 3.9 liters is my inspired reserve. It's the amount after I've normally inspired that I can still suck in more. Then we go from the end of our biggest exhalation, or a normal exhalation, to the end of our maximal expiration. And again, this isn't doing exactly what I want, so I'm going to pick that spot right there, which is even with my normal expiration, and I'm going to go from the normal expiration to max expiration, and it's about another 0.83 liters. 0.83 liters. Okay, well, 3.9. Now, what is my, first of all, what is my vital capacity going to be by definition? It's the maximal amount that I can blow out. Okay, so we're talking about 5 liters. So if we add the inspired reserve, we add the expired reserve, and we add the tidal volume, you know, those are the 3 I'm doing here. I'm going from the top of here up, I'm going from the bottom here down, then I'm also including this. That gives me my total amount of vital capacity. I'm going to use the numbers I measured. Okay, so if we have 0.5 and 3.9 and 0.83, let's just do 0.8, that's close enough. 5 and 14 and 8, 22, 5.2 liters. Well, I'll be darned, this says 5.1. I just let the machine do it from top to bottom. So 5.1 liters. Yeah, okay, we added up those 3 numbers and that's what we came out with. So the way that you would find out somebody's vital capacity is simply to add their tidal volume plus the extra suck and the extra blow. All right, that gives you all of it. So those 3 numbers, and on your sheet it even says it, vital capacity is tidal volume plus inspired and expired. You add them up, so my vital capacity is about 5.2 liters. What did we say it should be? At least 4.4. Great. Okay, so my vital capacity looks just fine for my height, age, gender, and all of that stuff. So we have the we have the FVC. That's what I did. This was suck and blow as hard as I could. I got my forced vital capacity test, which gave me my vital capacity number. I measured my tidal volume, so that was useful. I got a breath rate. We're going to say it was 12 breaths a minute, which is more typical, and it's what I've used for some of my other calculations. So all you do is, you know, you'd count these for a whole minute and see how many you had, you know, and, you know, if it's 12, then it's 12. If it's 14, it's 14. But we're saying that it was 12. That's close enough. Now, the other thing that we can look at here is we can look and see how much I blew out in the first second. Okay, well, here's, you know, here's the maximal, and from here, see, this isn't perfect for this particular job because it only gives you every 2 seconds. But we're going to go about a second here, from there to about there. It's about half the distance between 22 and 24. It looks like I blew out about 3.68 liters in the first second. 3.68. Okay? Let's say that that's what I blew. It's a little hard to tell because I can't get it exactly a second on here. But what if I blew 3.8 liters out in my first second? That is my forced expired volume in 1 second. What percentage is that of my total? Well, you go 3.68 divided by 5.2 equals 3. I don't need that to happen. Let's get rid of this. Can't answer the phone just now. Okay, let's try again. 3.68 divided by 5.2 equals 0.7. Okay, it should be 0.8. Well, maybe I didn't get this to be exactly a second. Or maybe, which is actually the case, I'm having a little bit of allergies from the pollen that's landing all over the property right now. So it could be that my slightly decreased percentage of getting my air out is truly due to a little bit of airway constriction. So it's situational. You have to look and see what it is. But we were going to put down that my FEV1 is 3.68. So we can write that, wherever you want to write it, off to the side or something. And you can say that that is 70%, which is actually 71%, which is slightly low. And so you might look for the reason why today, of all days, my FEV1's a little low. And it could be the pollen thing, or it could be my measurement here was off by 1/10 of a second or something like that. Okay, so that's the data collection. That's the way you look at the data. You just set this up to tell you the difference between 2 points. You go the max, what's the max? Oh, yeah, my max airflow. Remember I said this was going to be my max airflow when I was blowing out as hard as I could? Well, what's the max airflow? Max airflow. 5.7 liters. 5.7 liters per second was the fastest flow rate that I had. Well, that's pretty good. Remember I said maybe 4 to 6? And I'm an old guy, so 5.7 liters per second as my maximal flow rate, my PEF. So you could write down that too. 5.7 liters per second is my PEF. So there are a number of things we have. We have tidal volume. We have our PEF, the peak expiratory flow rate. We have the FEV1, the percentage of it that came out in the first second. We have the inspired reserve, the expired reserve. All the things we're getting just from me doing that short test with this system. And a lot of hospitals have systems that are at least as sophisticated as this, and some of them will automatically calculate those numbers for you. Unfortunately, you actually have to calculate them on the test, some of them. I'll show you which ones in the next short video where we look at the crunching the numbers.